Coroutines in Kotlin are a concurrency simplification feature that allows you to write asynchronous code more sequentially and readably. They work well with suspending functions for non-blocking operations, and you can create them using coroutine builders like launch and async. Coroutines are typically scoped within a coroutine scope for better management, and include mechanisms for handling exceptions and graceful cancellation, making them a powerful tool for efficient and responsive application development. Here is a code example in Kotlin that illustrates the use of several functions and keywords related to coroutines. RunBlocking creates the main coroutine block, blocking execution until all coroutines within it are finished. Async initiates an asynchronous operation, returning a deferred object. Suspend marks a function as suspending, used for operations that can block in coroutines. Launch starts a new non-blocking coroutine. Delay delays the execution of a coroutine. Join waits for the specific coroutine created with launch to finish. Await awaits the completion of an asynchronous operation and retrieves its result. Coroutines in Kotlin are versatile for handling asynchronous and concurrent tasks. They are commonly used for non-blocking I/O operations, e.g., network requests, database queries, background processing in user interfaces, efficiently managing large data sets, multitasking in console applications, aggregating data from multiple sources, handling asynchronous events, and preventing thread blocking, providing improved performance and responsiveness in a wide range of applications. Coroutines in Kotlin provide a flexible and readable means of addressing complex asynchronous and concurrent programming requirements across a multitude of application scenarios, leading to enhanced application performance and responsiveness. In the current example, I would like to demonstrate how to use coroutines along with dependencies such as Spring Boot Starter Web and Spring Boot Starter Data JDBC on a Tomcat server. The plan is to retrieve the user from the database and report with an HTTP request that the server has processed the request for a given resource. With context, dispatchers.io is a construct in Kotlin used to switch the context of a coroutine to dispatchers.io, optimizing it for non-blocking I/O operations like network requests. This allows the coroutine to perform I/O operations in the background without blocking the main thread and returns to the original context when the I/O operation is completed. In the next video, I will demonstrate the operation of coroutines with dependencies such as Spring Boot Starter Webflux and Preing Boot Starter Data R2DBC, so coroutines and the Reactor project in general. So remember to subscribe to stay updated.